Hello, this is Vincent Lissenberg and I'm a technical product manager for Sauce Labs' Backtrace product. In this short video, we'll see how to resolve errors and crashes in your mobile app. We make resolving mobile problems easier by automatic collection of relevant error and crash information, rich debugging metadata such as attachments, deobfuscation and symbolication of call stacks, device metadata and more, breadcrumbs, what user actions and system events occurred prior to the issue, source code integration, and automatic scrubbing of PII. In the previous video, we've seen how we can prioritize and choose what issues we need to work on, but how would we actually go about solving one of these problems? Let's take a look at Android first. For aggregation, Backtrace is able to show insights across all mobile platforms, but when it comes down to an individual report, we do see something different for Android, Java versus native crashes, and iOS exceptions and native crashes as well. So first of all, let's look at this call stack. Obviously, it's one of the most essential pieces of information that Backtrace would be able to show you. We would be able to show you an accurate call stack even if you would use an obfuscation framework like ProGuard, providing you provide the ProGuard mapping file to Backtrace. We're looking at a Java hang now, and we see that for a hang, all active threads are captured and the thread that is hanging is highlighted. For native crashes, the same applies in the sense that we would be able to show you an accurate call stack if you provide the symbols to Backtrace. These symbols can be provided to Backtrace during your app build. You can upload them automatically, or you can upload them manually. When symbols are loaded, even for a native crash, we will be able to show you a human-readable call stack. For Android, it is also possible to optionally enable client-side unwinding, which will try to locate debug files for system libraries such as libc on the device before uploading the crash information. This obviously has a performance impact. See that Backtrace can look up the exact location in your source code repository where the problem originated, which works fine for Java, Kotlin, C++ code, and many more. In this case, it's pretty obvious what the cause of the hang is. When we switch to attributes, we get an overview of a wealth of device metadata. All these attributes can be indexed, so we can query on them, such as show me all errors where the battery level is under 10%. You can also add custom attributes, easily using the API provided in our SDK. When we switch to annotations, we get an overview of error and system metadata. You see environment variables, these have been scrubbed of PII data. This is accomplished by a combination of client-side settings and server-side scrubbers for native crashes. Our breadcrumbs show us system events, low memory, network collection lost, as well as user actions, network switch, app switch, airplane mode turned on. SDK also allows you to add breadcrumb data via our API for your custom event. All this helps you to pinpoint what happened before the error hangs or crash happened, which can be more essential than the call stack for some problems. Through the SDK, you can add attachments for errors and crashes. More simple libraries usually don't allow you to add attachments for native crashes, and this is very useful for debug purposes. In the attachments, you would have access to the raw data files as well, such as the mini dump in case of a crash. Let's take a look at iOS. As with Android, we see a human-readable call stack. For the best accuracy, upload your DSIM files that are generated when your app is built and by the App Store upon publishing to Backtrace either manually or via the automated API. We see a lot of important app and device attributes, most of which are collected automatically. You can add your own custom ones via the API in our SDK. Backtrace also lists loaded modules and missing symbols for this crash. At the bottom of the call stack, we see some missing symbols for the Swift UI library, which is something that isn't uploaded to this Backtrace environment. You see that without symbols, the available information is pretty sparse. Also in iOS, attachments are uploaded for managed and native errors. These attachments could include screenshots, log files, save states, anything that makes resolving this problem easier for the developer. Thank you very much for watching.